Hello everyone and welcome back again. After I received the mechanical data from the mechanical engineer, which is the location of the HVAC system unit and the location also of the water heater, after that I will start to feed this equipment. Now see, I told the mechanical engineer that I need a plan, layout plan. Just give me the location, the exact location of this floor consists the false ceiling in the corridor and the offices. Now I know that all this equipment above the false ceiling. Now I will back again to the legend and I will choose the ceiling mounted outlet is 45 ampere. After also unpack to the catalog, I know all of this equipment is single phase. Now I will start to distribute this outlet near the equipment, copy, ceiling mounted outlet, also it is above the false ceiling. I know that all this equipment has access door for maintenance. Here, one, and again here I will put one also, and that here for this cassette, and also here this water heater is horizontal type above the false ceiling. Here also can put here, and again here also for this machine, and here one outlet, also here one outlet, and here one outlet. Also I forget to put one outlet here. After that, here this is a split unit. A split unit not required ceiling mounted outlet, so I will put wall mounted here single circuit outlet. Here this single circuit 40 ampere outlet, copy that and put it here near the split unit. And after we finish from distribution or outlet, we will back again to distribute also the disconnect switch to turn on or off the device. See here, we back to our legend. See, we have here two types of disconnect switch. One of them is 25 ampere single phase and the another is 45 ampere. Here in the electrical water heater, I have electrical water heater 100 liters. I will back to the catalog. See here, this is the type which I use, the company of the Global. See, I will attach this catalog with this lecture, but here I have the product 100 liters, this is dimension, height and width, and here the most important things for me, red watch. Here they mention that for 100 liter the power is 3 kilowatt. Suppose I have 3 kilowatt, I will divide it by voltage for single phase, suppose 220, then the ampere will be around 13 ampere. I think 25 ampere is enough. Here I will copy this. I will put it here near the lighting switch. remove. Also, I will change the location of this outlet little bit to be a clear the drawing. I will copy this connect switch 25 ampere for all water heater. See here, also I will put it on the right. And here also I have bathroom. The mechanical engineer designed the water supply and he put one electrical heater for the spot bathroom. Rotate. And also I think here in the kitchen he put also electrical water heater. We put here again to disconnect switch. And now here also I have two choice. I have here three type of heating and ventilation air conditioning as we talked in our lecture. I have here this duct split, and also here this a cassette for this kitchen, and I have here also a split unit for the surface room. See here this duct split in the mechanical room that the duct go from here through this office. He feed this machine feed this office number 1 and office number 2. For me, I will not put a disconnect switch because maybe the operator will be confused to operate the air conditioning, but I will put only for this two unit, the cassette unit and the split unit. I will put for them here a disconnect switch 45 ampere. It is optional. You can put also disconnect switch for all the duct type, all the duct split types. Here this is a 45 ampere. Here also we will put for the split unit in the surface room. But as I'm saying, it is optional. You can also put for all those type of HVAC system, you can put for them disconnect switch. And now the next step is put the conduit or the wiring for this device. Now for this disconnect switch, I will connect them at the beginning for this outlet, and after that I will go from this disconnect switch to the panel port. This is a circle. Now I will choose the polyline again. See here in the outlet 25 ampere. Here disconnect switch, and after that from this disconnect switch, polyline, this disconnect switch, I can connect it to the distribution panel or delete. Or mention only that it will go to distribution panel port as we make for the lighting and power outlet. See here, this is for lighting, and here this is for outlet and air conditioning. Now, which is the number, what the number of the circuit I will mention. If I want to put my outlet and air conditioning in one panel port, that I will start from the last circuit in the panel port. See here, I will back to the outlet, power outlet. See here, the final circuit here is 25 ampere. That means I will start here from 26 P, or I can mention AC 26 to FDP PWR. This is the name of the panel. I will move it a little bit, and now I will pack to the catalog to be sure if this air conditioning is single phase or three phase, and how much of the watt of these devices. Now I asked the mechanical engineer. He told me that he designed his work with LG brand, for example. Now see here, this is a duct split catalog. Now I have three size of the duct split units: 36 BTU and 60 BTU and 42 BTU. Now if I want to extract electrical data for 36 AWY, this is the name of the brand, because it is 36,000 BTU or 3 ton. Now see here this table. We mentioned that this is the data for the brand 30,000 BTU, and this is for 36 BTU, and here 42 BTU, and here 55 BTU. Now I need a 36 BTU and 42 BTU, 36,000 BTU. Why? Because he mentioned here in his design that the capacity of the cooling is 42,000 BTU. Now here, see the capacity by kilowatt. This is for HVAC. This is a mechanical unit. I need here the power input. We talked in our lecture about the BTU and the ton, refrigerant, and so on. We mentioned here the kilowatt capacity of cooling, here 32, and so on. But we required here the power input. See here, for cooling by kilowatt and heating by kilowatt. If we go here in our 36,000 BTU, it will be 2.9, and also here 3.28 kilowatt or 3,280 watt. And here, see here, we mentioned that the voltage is 230 to 240. This is single phase. This is the hertz, 50 hertz. Now I know that this unit is single phase, but here for the unit we have we have a unit here. See here, this unit is 60,000 BTU. Now I will pack again to the unit 60, here 62. I will pack to the mechanical engineer. Are you mean that this is the unit B62 AWY N9L6? If he confirm me, I will pack to the data. See here the power input and the cooling and heating. I can take the maximum value 5.49. This is the capacity by kilowatt. And here he mentioned that the power supply is 380 to 415. That means it's 3-phase. He mentioned here also this is 3 by 50 Hz. Now I know this unit is 3-phase. How can I deal with? Don't worry, I will explain everything in the panel port chapter. Now I will complete to make all the circuit. Welcome back again. Here now, after I'm finished from all the conduit and the circuits, now the final result, and extract all the load value. Here see, I'm starting from AC26 as I'm saying. This is A26, AC26, and after that also the circuit will be AC27 and 28 and so on. See here, I make this conduit by the Dutch line to refer that this is EMT conduit. And also here I have 2 units, 3-phase, as we said, 60,000 BTU the watt. See here, this is the outlet going to the panel port. And refer that the circuit is number 37, 39, 41. This is for 3-phase. And here also we have a bucket 60,000 BTU, duct split FCU number 5. Also I'm refer here the number of circuit 38 and 40 and 42. See here, this is the final value of the load. Why I'm past 36? That we know all these details in the panel port and load schedule calculation in the next chapter. Thank you for watching, and we will move to the chapter number 4.